Lecture 7, Divergence of a second order tensor, attention, in non-conservative form. You see, the divergence, okay, let's start first using the components of the second order tensor. This belongs to the vector space, okay? The basis AP, AQ also belongs to the vector space. So let's use, you see, this nabla operator over here in the conservative form. See, I substitute here this by this, okay? Now I repeat, this is nabla operator in the conservative form. Now, expansion of this divergence of the second order tensor. Okay, just as a derivative, a product rule here. Okay, so AI now you have three terms. Okay, because we have three variables. T, PQ, AP, and AQ. They vary. Okay, that's important. Point to point. So again, use the Stoffel symbol, the relation. This is a partial derivative over here is gamma. You see, that's important because IP, okay, they are free indices and covariant because I is in the denominator. So this is gamma IP, M, AM. There's a vector. Attention, this is a vector. Likewise, partial IQ is gamma IQ M AM. So rewriting this, I just substitute this on here and here. Then this leads to this relation here. Okay. Now, attention now. Okay. AI dot AP is dot product. This is the correct delta IP. So delta IP acts, okay? There is a property, okay, of delta IP. So this will be IQ. You see, look, you can see here the P over here, okay? Delta IP, okay? It acts on P, this is I, okay? AQ. That we did a lot of before. So this divergence, or this tensor, second order tensor, written in using the components of the vector space. So we can, there's a vector, see, there's a vector. Attention now, divergence of a second order tensor is a vector. You see, the order of this tensor, okay, it was lowered, okay, to 1. That's a vector. So I can represent only these components over here, okay, which I can write right there. Attention now, you see, P over here is dummy, okay? You look at that, Q is a free index. It is red, you see? Q is free. So this, I can write P, doesn't matter, or M, or N, or S, because P is dummy, no problem. Now, also, likewise, I could derive the expansion, attention now, this here belongs to the dual vector, or covectors, okay? You see, this is covariant components, this is the basis, okay? They belong to the dual vector. You see, it's analogous, okay? You just substitute this operator over here, expand this derivative, and do the same. Okay? We did analogous to this when you derived covariant of a tensor. Okay? Just in previous lectures. So that's all. So this is divergence, okay? Divergence of a second order tensor. So these are the components only, the component, okay? You see this minus over here, this comes from, I take the derivative of AP, you see, contravariant with respect to Ci. And this one, I take the derivative of AP, the contravariant AQ, with respect to Xi. So this is minus over here. This we did before, okay? So in this here, attention now, those are the components, okay? Here, IPQ, they are free indices. You see IPQ. You see the IPQ. You see IPQ. Oh, look, M here is dummy. M is dummy. So these are free indices. This is a covariant free index, all of them. This is not. Okay, this only Q is free index. That's it. That's a divergence of a tensor. We could derive divergence of a third order tensor, fourth order tensor, and so on. You see? So the development is analogous. Okay, no confusion. Okay, you can do the same analogously. Okay.